Hello, and welcome back to another episode of Math with Dr. War. Today's lesson is on the set of real numbers, which includes two major classifications of numbers, irrational and rational. If you're new, my name is Dr. War, and I make Tasc mathematics videos to help anyone out there who is trying to pass their Tasc exam, especially the Tasc math test. So if you like the content, please subscribe and like. Let's begin. Now, before we start talking about rational numbers, we need to define what types of numbers there are out there in math land. In the innermost circle, I'm going to label that number 1. We have counting numbers. Counting numbers consist of 1, 2, and 3. Now, some mathematician calls them natural numbers, like myself. I call them natural numbers. So if you have a natural number, which is considered a counting number, they start from 1, 2, 3. Because if I gave you some marbles and told you to count them, you would start with 1, 2, and 3. So always remember, your counting numbers consist of 1, 2, 3. Next, we have our whole numbers. Now, your whole numbers are defined as your counting numbers, because remember, 1, 2, 3 is the counting numbers, and 0. So if you have the counting numbers and zeros, you have whole numbers. Next, we have integers. Integers are defined as your whole numbers, because remember, your whole numbers are 0, 1, 2, 3, and their opposites, -1, -2, -3. So if you have the whole numbers and their opposites, those are considered your integers. Now your counting numbers, your whole numbers, and your integers are rational numbers. These are what I consider the foundation of rational numbers, because we use these to build other types of numbers, which may be rational numbers. Now, a rational number is defined as any number that can be expressed as a ratio of two integers. Now, when they say a ratio, they mean a fraction. So if you can express a number as a fraction of two integers, then it is rational. Suppose I have 1 over 4. This would be considered rational. Why? 1 is an integer and 4 is an integer. And aren't integers rational numbers? Yes. I don't care what fraction I give you. 1 over 4 is proper. Suppose I give you an improper fraction, 3 over 2. This is rational. 3 is an integer and 2 is an integer, and integers are rational numbers. So therefore, 3 over 2 is rational. I can give you a mixed number, 2 and 3 over 4. Now to build this mixed number, we had to use integers. 2 is an integer, 3 is an integer, 4 is an integer. Because all of these are integers are rational numbers, this mixed fraction is a rational number. It could be even negative. I could give you -5 over 11. This is a rational number. -5 is an integer, 11 is an integer. Integers are rationals. Therefore, this is rational. If you can express it as a fraction, it is a rational number. Now, if you have a decimal that has a repeating pattern, it is a rational number. And you can identify those decimals. You see them all the time. Suppose you saw 0.33, and then this 3 had a bar at the top. Now, that bar is telling me that the 3 is going to repeat itself infinitely. So that's going to be 0.33333333 forever. So once you see this bar right here, you know what's going to come next. Therefore, it is a rational number. Suppose you saw 0.625 and the bar was on top of the 25. Then you know this number is 0.625, 25, 25, 25, going on infinitely. So therefore, it is a rational number. Now, if you have a decimal that terminates, it is a rational number. Now, when I say terminate, I mean ends. So suppose you saw 0.25. Now, this is a decimal that ended, it terminated. So therefore, it is rational. Suppose you have negative 7.125. This decimal terminated. Therefore, it is rational. Always remember, rational numbers are fractions, there are decimals that have a repeating pattern, or a decimal that terminates. Now, there's another one that I'm going to include. Rational numbers are perfect squares. And by a perfect square, I mean this. Suppose you saw the square root of 64. Now, no one walks around and talk about the square root of 64. Well, Drake did in his video. Okay, I can't remember the name of the song. But I know he said something with square root 64. Now, no one walks around and say the square root of 64. You have to simplify it. The square root of 64 is 8. Isn't 8 an integer? Therefore, it is rational. And when we say perfect squares, the square root of 64 is the square root of 8 times 8. 8 is multiplying itself. Remember, square roots, when you have to find them, you're looking for that number that is multiplying itself. Square roots always go with the operation of multiplication. So the square root of 64 is 8. Therefore, it is rational because 8 is an integer. Suppose you want the square root of 81. That would be 9. 9 is an integer. Therefore, the square root of 81 is a rational number. So let's recap. Rational numbers are integers. I'm not going to say whole and counting because integers is encasing all of those. Because remember, integers are your whole numbers and their opposites. So I'm just going to say integers. Rational numbers are your integers. They are your fractions. They are your repeating decimals, your terminating decimals, and your perfect squares. Now, if you're not rational, it means you are irrational. Now, an irrational number is defined as any number that cannot be expressed as a ratio of two numbers. So an irrational number basically is when you can't get your number to be expressed as a fraction. So it's like the opposites of rational numbers. Therefore, if your decimal does not repeat or terminate, it is irrational. And we've seen those numbers. Have you seen a decimal such as this? 1.2563727, and then you see a couple of little dots at the end. If you see a number such as this, it is considered irrational. Reason why is that this number is going on infinitely, and you don't know what's going to come next after the 7. So the person who wrote the number just decided to truncate it. Truncate means just to cut it off. And just put some little dots to say, okay, this number is going on forever. This would be considered an irrational number. Numbers with special names, such as pi. So if you see the symbol pi, if you see the symbol pi, it is irrational. Pi goes on forever. The value of pi can fit into a notebook and keep going. It is not just 3.14. It goes on forever. So pi is considered irrational. So if you see the symbol for pi, it is irrational. If you see not perfect square roots, they are irrational. And what am I talking about? The square root of 7. 7 is not a perfect number. And if you take the square root of 7, let me get my calculator. So in order to take the square root, with your calculator, you need second function. Because the square root symbol here is in green, you need to press second function in order to access that function there. And then you press the x squared, Notice the square root symbol is there, and inside it's flashing. So let's enter 7. Now we need to get out of the square root. Go to the right. Notice the cursor is right there at the end. And now I'm going to hit enter. Now when I hit enter, you're probably saying, well, it looks the same. Okay, yes, it does look the same. But you need this function right here, and it's called the toggle. Now when you press the toggle, notice the calculator gives you 2.645751311. However, this number has not ended. It's still going. It's just that the calculator truncated it. They cut it off because the screen is not that big. Therefore, the square root of 7 is an irrational number. It's a little bit different. Suppose we did the square root of 16. So if I did second function x squared, and I enter 16, and I went to the right, and I hit enter, notice I got 4. Notice there are no decimals. It's just for the integer. That's why this is rational, while this is irrational. So a number is irrational if you cannot write it as a fraction. Therefore, when you see these numbers that are very long decimals with little dots at the end, they are irrational. Pi is the most famous irrational number for us. If you cannot take the square root of the number, and I always tell my students, in your head, then it is irrational. So that's your definition of rational and irrational. Now you're going to have to know what happens when you add, subtract, multiply, and divide your irrationals and rational numbers. Now let's start with adding and subtracting. Now if you take two rational numbers and add them or subtract them, the result is rational. So if you take a rational number and add it with another rational number, you should get a rational number. 6 is a rational number, correct? Because it's an integer. If I add it to 5, which is another rational number, I'm going to get 11, which is an integer, which is a rational number. If you take a rational number and subtract it from another rational number, you're going to get a rational number. Suppose I have 9 over 5, and I'm subtracting from 4 over 5. Now 9 over 5 is a fraction, so it's rational. 4 over 5 is a fraction, so it's rational. And if I subtract these two fractions, I get 5 over 5, which simplifies as 1. Isn't 1 an integer? So it is rational. Even if you have some decimals, suppose you have 0.2 and you're adding it to 0.8. 0.2 is a terminating decimal. It is rational. You add it to another terminating decimal, which is rational. You're going to get a rational number. When you add these two, you're going to get 1.0, which is a rational number. So if you add two rationals or you subtract them, you get a rational number. If you take two irrational numbers, okay, and you add them or you subtract them, you get an irrational. So if you take an irrational number and you add them or subtract, you're going to get an irrational. So suppose I had pi and I added it to, let's say, the square root of 2. That would give me an irrational number. Pi is irrational. The square root of 2 is irrational. So therefore, you're going to get an irrational. If I took the square root of 7 and I subtracted it from, let's say, the square root of 15, square root of 7, I can't take that square root in my head. I'll need a calculator. So irrational. And I'm subtracting from the square root of 15, which is another irrational. So guess what I'm going to get? Irrational. Now on the test, they don't want you to get the exact value. They just want to know whether your result would be rational or irrational. Now, if you take an irrational number and a rational number and you add or subtract, the sum is irrational. So if you take an irrational number, I'm going to write IR, and add it to a rational number, your result should be irrational. So suppose I took pi and add it to 6. Now pi is irrational, 6 is rational because it's an integer. that result would be irrational because all you're doing is adding 6 to pi. So now it just increased by 6, but it's going to keep going infinitely. If you take an irrational number, let's say the square root of 7, and you added it to, let's say, a half, it's going to be irrational. 7 is irrational, and you're adding it to a half, which is a fraction, which is rational, your answer would be irrational. Multiplication and division, though, is a different story. When you multiply or divide two rational numbers, your result would be rational. So if you take two rationals and multiply them or divide them, the result is rational. When you have an irrational number, and by a non-zero rational number, they mean you can't use zero, okay? Non-zero means don't use zero as your rational number. So if you have an irrational number and a non-zero rational number, and you multiply or divide them, the product is irrational. Now, when you take two irrational numbers and you multiply or divide them, the product is sometimes rational and sometimes irrational. So when you're multiplying and dividing and you take two irrationals and you multiply or divide them, you might not get what you think. For example, I'm going to put it down here. So suppose I had the square root of 5, and I'm multiplying that by, let's say, the square root of 5. So the square root of 5 times the square root of 5 is actually, let's just have one square root, and 5 times 5 is 25. And the square root of 25 is 5. And 5 is an integer. Therefore, the result turned out to be rational. So I took an irrational and multiplied it by another irrational and got a rational number. I can take square root of 5, and let's say I'm multiplying it by the square root of 7. This would give me the square root of 35. 35 isn't perfect, so therefore this one would be irrational. When you take two irrational numbers and you try to multiply or divide them, sometimes you don't know what you will get. You might get a rational number, or sometimes you will get an irrational number. So this is very important. I always tell my students, you don't know what you get when you put two irrational numbers together. That's like when you put two irrational people together. You don't know what the outcome will be. They might be good, or they might be, let's just say, bad. With this information, you're going to have to use these to answer questions on your Tasc test. So let's look at what these questions will look like. So here's our first question. For which values of P and W is P plus W a rational number? Now I look here at the P and the W for number 1. Now I'm not going to focus at the top. Now they look like fractions, but you see a radical, so don't go crazy and say that they're rational numbers, okay, just because you see a fraction. I see a radical sign, so you need to take a little step back. Now I'm not going to look at the numerator, I'm going to look at the denominator. Now we want to add these two. I'm going to put a plus sign there. Now, can you take the square root of 3 in your head? No. Can you take the square root of 6 in your head? No. So P is an irrational number that you're adding to another irrational number. So your result would be, yep, you got it right, irrational. You add two irrationals, add. You're going to get an irrational. Let's look at number 2, which is P and W. Now we have to add them because they want us to add. Focusing on the square root. Now the square root of 4 here is 2. So this P is actually 1 over 2. Plus, here this would be 1 over, and the square root of 9 is 3. The half is rational, which you're adding to a third, which is also rational because they're fractions. Therefore, your sum is going to be rational. If you add two rational numbers, you're going to get a rational. So your answer is number 2. Your answer is not 3 because the square root of 6 is irrational. And the square root of 10 is irrational. And if you add those two, you're going to get an irrational. With 4 here, yes, we know the square root of 25 is 5. So this is rational. However, you can't take the square root of 2. So this would be irrational. And if you add a rational with an irrational, you're going to get an irrational. So you have to be able to identify rational and irrational numbers, and then you have to know what happens when you add them, subtract them, multiply, and divide. The second one says, given L equals the square root of 2, M is 3 square root 3, N equals the square root of 16, P is the square root of 9, which expression results in a rational number? Now I know that the square root of 2 is irrational. Now I tell students I know it's irrational because I know I can't take the square root of 2 in my head. But if you get your calculator, remember you go second function x squared to get the square root symbol. And then I'm going to put 2 in there. Go to the right and I hit enter. Okay, you're going to get the square root 2. Press the toggle. Notice the number you get. A decimal that is going to keep going. So I know that is irrational. Now here I have 3 square root 3. Now the 3 here is rational. But remember, the operation going on between these two is multiplication. So the rational 3 is multiplying the square root of 3, which is irrational, because you can't take the square root of 3 in your head. So a rational times an irrational is an irrational. If you want to put it in the calculator, just to prove to yourself, 3 second function x squared, 3 again, to the right, enter. You're going to get 3 square root 3 because that looks nice. But when you press the toggle, notice you get this very long decimal. But we didn't need the calculator for that. 3 is rational, the square root of 3 is irrational, and when you multiply them, you're going to get an irrational. Now, square root of 16, the square root of 16 is 4. Therefore, this is a rational number because 4 is an integer. The square root of 9 is 3, and 3 is an integer. Therefore, it's rational. So I am looking for N and P. So where is N and P? Right here. So your answer is number 3. Which expression results in a rational number? Okay. Number 1, I have the square root of 121. I know that simplifies to 11. So it is rational. And I'm subtracting the square root of 21. Now I know I can't take the square root of 21 in my head. So that is irrational. If you want to check and you're on the test and it's the calculator section, you can go ahead. Second function, x squared, 21, to the right, enter. You're going to get back square root 21, toggle. There's your messy little decimal. This is going to be irrational. If you take a rational number and you subtract an irrational number, you're going to get an irrational number. It's like the irrational number outpowered the rational. Over here, I have the square root of 25 times the square root of 50. Now I know the square root of 25 is 5. So therefore, this is rational. And I am multiplying by the square root of 50. Now I know 50 is not a perfect square like 25. Therefore, the square root of 50 is irrational. If I take a rational and multiply by an irrational, my answer is irrational. Again, the irrational outpowered the rational. 3, I have the square root of 36, divide the square root of 225. Now, the square root of 36 is 6, divided by the square root of 225 is 15. So these two square roots are perfect. And when they simplified, I get 6, which is a rational number because it's an integer. and 15, which is a rational number. And when you divide two rational numbers, you get a rational. So your answer is number 3. 4 is not your answer. I know I can't take the square root of 5 in my head, so this is a rational. And then you have the square root 5 again, so that is a rational. And remember, when you add two irrationals, you're going to get an irrational. I think of adding and subtracting irrationals as like petty crime. You know, you just get like a slap on the wrist. Petty crime. So they still are irrational. Let's look at another one. Which expression results in a rational number? So I have here the square root of 2 times the square root of 18. Now the square root of 2, I can't take the square root of 2 in my head, so that's a rational. And I'm multiplying by the square root of 18, which is another irrational. But remember, when you multiply two irrationals, your answer can be irrational or it can be rational. So I'm going to evaluate this to figure out, do I have an irrational or a rational? So 2 times 18 is 36. 36 is perfect. The square root of 36 is 6. Therefore, this is rational. So your answer is number 1. If you're on the test and it's in the calculator section, you can pick up your calculator. Second function x squared, 2. Go to the right, multiply. Second function x squared again. To get the square root symbol, you're going to enter 18, go to the right, and then you hit enter. And you get 6. 6 is an integer. Therefore, it is rational. So sometimes you can't trust these square roots, you know. Over here, 5 is rational. And you're multiplying by the square root of 5, which is irrational. And when you multiply a rational times an irrational, yeah, you will get an irrational. Square root of 2 is irrational. And you're adding it to square root of 2 again, which is another irrational. So petty crimes. So when you add those together, you're going to get an irrational. Just a slap on the wrist. Number 4, you have 3 square root 2, focusing on the square root 2, irrational. And you're adding it to, focusing on the square root 3, irrational. 2 petty crimes. Irrational plus irrational will give you irrational. So when you're adding two irrationals, I consider it petty crime. However, if you're multiplying two irrationals, that's like, I'm sorry I'm talking about crime. I have no idea why I'm talking about crime. This is like manslaughter and murder. And sometimes people that are on manslaughter charges and murder charges, they get off rational. And sometimes they go to jail for a very long time, irrational. So you don't know. But you know, petty crime, like when you add in them, slap on the wrist, you're probably out tomorrow. Don't do it again. The product of the square root of 576 and the square root of 684 is. Now these numbers are really big. I would think this question would come on the calculator section. We're going to need our calculator. Second function x squared. I'm going to enter 576. Remember, go to the right. And I'm going to hit enter. Now the square root of 576 is 24. And remember, we're multiplying. I'm going to put a dot. Second function, x squared. I'm going to enter 684 to the right. Enter. Okay, that gave me a value of 6 square root 19. Now the 24 is rational. Because I see the square root 19, which isn't going anywhere. And if you press the toggle, notice you get all of those numbers. So you know they're going forever. Square root 19 is making this irrational. So if you have a rational and you multiply by an irrational, your answer would be irrational. My answer is not 2 or 4. So why is it irrational? Okay, is it irrational because both factors are irrational? No, it is irrational because one of the factors is irrational. So your answer is 3. Given the following expressions, so we have 4 expressions here, which expression or expressions, could be more than one, results in an irrational number? So let's look at number 1. Now I have negative 5 over 8 and I'm adding to 3 over 5. Negative 5 over 8 is a rational number because it's a fraction and you're adding it to another fraction, which is a rational. And if you add two rationals, you're going to get a rational. So number 1 is a rational. I know my answer is not 3 because I see 1 right there. Okay, let's look at number 2. Number 2, I have a half, which is rational because it's a fraction, and I'm adding it to square root 2, which is irrational because I can't take the square root of 2 in my head. I would need a calculator. And if you add a rational with an irrational, you're going to get an irrational. So number 2 is an irrational. Let's look at number 3. Number 3, I have the square root of 5, and I'm multiplying by the square root of 5. Now the square root of 5 is irrational, and I'm multiplying by another square root of 5, which is irrational. So this is 2 big level crimes here, murder and manslaughter. So you don't know what your sentence would be, freedom or jail. Figure it out. This is easy numbers. 5 times 5 is 25. The square root of 25 is 5. 5 is an integer. Integers are rationals. So these 2 irrationals got off scotch-free. So this is rational. So number 3, okay, so my answer is not 2 and my answer is not 4 because this is rational. So your answer is number 1. However, let's go on some more. Number 4, I'm going to put it up here. You have 3 times the square root of 49. Now 3 is rational because it's an integer and you're multiplying by the square root of 49. You can evaluate the square root of 49. It is 7. 7 is an integer. Integers are rational. When you multiply two rationals, you get a rational. So notice 1, 3, and 4 were your rationals and only 2 was your irrational. And that's how you solve these problems. You really don't need the calculator. You just need to know who is an irrational number and who is a rational number. Which statement is not always true? Not always true. And I tell students, when you see that word, not always true, you know it's the 2 high crime people. 2 irrational numbers either multiplying or 2 irrational numbers dividing each other. So whenever you see 2 irrationals multiplying or dividing, that high level crimes, you know it's not always true. Tell students, when you see that word not always true, start looking for the 2 irrationals. So the product of 2 irrational numbers is irrational. That is your answer. That is not always true. The product of 2 rational numbers is rational is always true. The sum of 2 rational numbers is rational is always true. The sum of a rational number and an irrational number is irrational is always true. But when you have to multiply 2 irrationals or divide them, and the key here is multiply or divide, it is not always true. Be careful with the wording. And the last one is the product of square root 16 and 4 over 7, rational or irrational. So we know product means to multiply. Now the square root of 16 can be simplified to 4. 4 is an integer, so it's rational. 4 over 7 is a fraction. All fractions are rationals. And when you multiply 2 rationals, you get a rational number. And I explained it as I did it. I hope this lesson has been helpful with identifying the operations of rationals and irrational numbers. Again, if you like the content, please like and subscribe. I hope this lesson has been helpful. Good luck in your Tasc examination.